Hello and welcome. In this problem, we want to do an energy analysis of a car, an internal combustion engine or ICE car, accelerating from 0 to 75 miles per hour. We want to find how much fuel is consumed. Sounds like a hard problem, but if you look at the given data, it's really a simple problem. So we can easily calculate the change in kinetic energy in this problem. All the data are supplied. And then an energetic efficiency, the thermal efficiency is given, which means it's heat release to kinetic energy. So essentially, if I divide that by the efficiency, which is 0.2, then we'll get the amount of heat release necessary. And a kg of fuel produces 40 million joules, which is known as the heating value. So then we divide that by this heating value, and then that will tell us exactly how much mass of the fuel is necessary. So once we know how much mass of fuel is necessary to accelerate the car, the rest is quite simple. Knowing the fuel density, we can convert the amount of fuel to meter cube of volume and use the unit converter to find how many gallons of fuel is consumed. And knowing the price in dollar per gallon, we can calculate the exact price. So it's a matter of organizing the problem into several different blocks and using the unit converter when necessary. So what we are going to do is to launch the DeskCal app. I'm already logged in as a student. So we click on the test apps, DeskCal, and this leftmost tab launches the app. So first thing first, we write down the given information and given values. Obviously, the mass in pounds is given to be 6,000. Velocity, so likewise, I've already listed what is given in this screen, so I don't want to repeat that. So let me walk you through that. Velocity at state 2 is 75 in mile per hour. Velocity at state 1 is obviously 0. Efficiency of the ICE engine is 20%, 0.2. The heating value of the fuel is 40. Fuel density is 800. And price is $3 per gallon. Notice all the units at the end of the variables. If I click the calculate button, all of these values are now registered and displayed in the output area. Now the task is, in this block, we are going to convert these values to SI units. And so mass in kg is obviously mass in lbs or pounds time. We can go to the unit converter and pick up that. And you have, in the previous problem, I have done so, but you can easily do that again if you want to. So you can search for mass, go to mass, and then 1 kg is so many pounds. 1 pound is 0.454 kg. So this is the way we convert 0.454, so we know mass in kg. Similarly, I've done that for velocity in this screen. So velocity is 0.447. It would be nice to write a little comment here. For instance, we can write a little comment using the unit converter. Okay, so velocity at 2 is this much. Velocity at state 1 is obviously 0, but so, and the heating value is given in million joule per kg, so you convert that to kilojoule per kg. And now starts the analysis, or you can call it energy analysis, really. So what we know is that the change in kinetic energy is the easiest to calculate. So for that, kinetic energy at 1 equals what? Mass in kg times velocity 1 in kg, square of that divided by 2000. Obviously that's 0. The kinetic energy at 2, I can just, with quick way, copy paste 2 everything else remains the same. So we can find that we have calculated velocity, okay, K1, sorry, I forgot the unit, kilojoule. Oh, there is several mistakes, sorry. That's why notice that the calculation got stuck at hitting value because velocity 1 kg, there is nothing like that. Velocity 1 is in meter per second. Now we'll find at least K1 has been calculated. Similarly, velocity 2, the variable name is meter per second. Okay, so now, what mistake did I make this time? Calculate. Okay, Ke2 is found. So Ke1 and Ke2 have been found. So let me just take you to another screen where I have finished the calculation already. So the delta kinetic energy is given by change in Ke2 minus Ke1. Heat release is given by the delta kinetic energy divided by the change in kinetic energy divided by the efficiency of the car, which is eta ice. So the fuel consumed will be heat released divided by heating value in kilojoule per kg. Similarly, fuel consumed in meter cube now, to find the volume of the fuel, we know the density, fuel density has been given to us. Therefore, the volume in meter cube is a simple formula. And finally, fuel consumed in gallon. We can convert 1 gallon is 1 meter cube is how many gallon. For that, we can again go to the unit converter and search for, let's say, gallon. Oops. Okay, volume. Here's the volume. 1 meter cube is how many gallon? Gallon should be towards the bottom because all the English unit related quantities are towards the bottom of this list. So 1 meter cube is 264 gallon. That's what we substituted there. So therefore, the fuel volume consumed, fuel consumed in gallon is given by this. So fuel cost is dollar would be how many gallons have been consumed by times fuel price in dollar per gallon. And finally, fuel cost in cents is simply 100 times fuel cost in dollar. So all the answers are displayed here. So this is our answer to part B. And the first part was how much fuel was consumed in fuel consumed in kilograms. So this would be our answer to part A. So now we have the entire test codes here, and which solves this problem. We can go back and change any value. Say if we say, hey, how much, if the mass of the car was, say 9,000 pounds, what would be the cost? And likewise, you can change any variable and just simply click the calculate button to see its effect on the answers.